Boaz Ziniman. I'm a technical evangelist from AWS, Amazon Web Services. I'm coming from Israel, part of the local team in Tel Aviv. And I would like to talk to you about AWS Greengrass and IoT compute at the edge in general. Thank you for staying for the last session of the day. We're going to have some technical information about AWS IoT solution, about Greengrass. We're going to do some demos, so prepare your mobile phones. You're going to need them. And before we go and talk about IoT, I just would like to remind you that please use the app to ask questions and to rate this talk. This feedback is super important for me, and I really appreciate if you give me feedback. I'll give you another way to give me feedback later on. So let's talk about IoT, and let's talk about the concept of IoT at AWS. So the way we're looking at IoT, there are basically three different layers. There is the layer of the things. It can be devices, it can be sensors. They can sense and act and generate information, and you can use this information. From the other end, we have the cloud. And the cloud allows you to store this information and use computing power that usually those things are lacking because they usually with a very small CPU, very small storage, and you can extend those things into the cloud. And the third layer is the intelligence. It's the ability to take this information and to understand the data coming from your things, and to understand the data and analyze it and perform actions based on this data. So those are the basic components we are talking about, and we're providing different tools to work with these components. So when we look at the architecture, there are several components which we should be familiar with. The first one is IoT Core, which we're going to talk about in a second. And the second one is everything happening with your things, which Greengrass is one of the main components we are going to discuss when talking about this specific part. In addition to that, we recently released several additional features that are mainly targeted to customers running large fleets of IoT devices. And we're talking about fleet onboarding, management, and software update. We're talking about audit and protection, everything related to security. And the previous talk was brilliant as a warm-up act for my talk. So everything related to security of your fleet of things you can manage with these services. And last but not least, everything related to analytics, taking the data from your IoT devices, analyzing it, understanding it, performing actions. Bless you. Now, let's focus on our first component, and this is AWS IoT Core. And AWS IoT Core is our tool to allow you to connect IoT devices into our cloud. And there are many different features we provide for that. We're going to talk about each one of them in a second. And there are some advantages you should be aware of when working with AWS IoT Cloud. First of all, we are trying to make the life of a developer, of a company developing IoT solutions, much easier. And this is a very important part of AWS IoT Core. And first for all, everything related to security. The ability to connect your devices in a secure way into the cloud to make sure that nobody can sniff the information coming from your things and nobody can send information that is not allowed, and of course managing at scale. And this is a very important piece of it, the ability to take everything I'm showing you here and run it in very large scales. And we have customers doing that with hundreds of thousands of devices, with millions of devices. The other thing is to be able to connect applications in a simple way to your things or control your things with applications by using some of the features we're going to talk about that are part of AWS IoT Core. Read messages, route them, use the information coming from the things, and act based on data coming from your things is another feature. And I think, at least from my perspective, one of the most important parts is the ability to connect to any AWS service out there from the IoT platform. So if you need storage or analytics or AI, or mobile development, or anything like that, you can easily connect from your IoT thing, from your IoT core, into those services. And we're talking today about more than 100 different services on the AWS platform, and you have access to all of them from AWS IoT Core. So let's talk about some of the features that we provide you with AWS IoT Core. So first of all, security and identity services. The ability to recognize the things, the ability to provide certificates. It can be our certificates, it can be your certificates. And with IoT, we have several challenges that we don't have with regular applications, especially web applications. When you're going to a website and you're checking the address and it's HTTPS, you know that you are talking to a website that you can trust, that somebody validated the owner of this website, and this is actually your bank and not somebody else that's trying to be or trying to look like your bank. With IoT, if this is an IoT device, my clicker is an IoT device, I need to make sure that this specific device can connect to a specific service, send messages or receive messages, and I need mutual authentication. And this is one of the challenges, and identity services will solve you this challenge. It will provide you the certificates needed to deploy into your devices, connect everything together, and you can use different types of security. And in addition to certificates, you can work with IAM and AWS IoT to define security inside the AWS platform. So for example, which IoT device or which IoT action can perform which actions on top of other AWS services. You can integrate Amazon Cognito. This is our user management tool. And you can have federated users and many other features that are related to security. The second feature I want to talk about is the device gateway. And this is what allows you to connect those devices, those things, into our platform. And it can support MQTT and WebSockets and HTTP, and you can sign and encrypt the information going from your things into the cloud and basically create a solution that is secured end-to-end, from your thing to the cloud, to third-party services, to your application, or anything like that. Then we have the message broker. And the message broker is taking the information coming from your things, or might be information that you're sending to the things, because we support both pub and sub. So you can publish information, you can subscribe to information, and route it to the right places. It uses topics, so you can have all kinds of structures of information. Like for example, if I have a smart house, a smart home, I can have my home as one topic, a specific room as a subfolder on that, and a specific device like my fridge or my coffee machine or my ice maker, whatever you can put in a smart home today, as topics under this specific room. And then I can query a specific room, I can query my entire house, I can query a specific device using very simple SQL-like queries. I'm going to show you it in a second. Of course, we support quality of service, and you can define if messages must arrive, or in some cases, you're okay with losing some of them. So based on the specific use case of your application. The next one, and super important one and very powerful tool, is the rule engine. And the rule engine allows you to go and write super simple queries. SQL-like, you can see I have a query here that basically looks like any other SQL query that allow you to query specific information coming from specific topics. And in this case, I have select star from topic structure where temperature is higher than 35. And then I can connect this specific rule into an action. For example, run a Lambda function, run code that will alert the maintenance team that a specific room or a specific device is running on high temperature and somebody needs to go and fix it. And this is just one example. And of course, you can connect to many other AWS tools by using rules and define rules that saying if something is happening, send the information to this Kinesis stream, or store this information in Elasticsearch, or run a Lambda function, or anything like that. And it's a very powerful option for you to connect the information coming from your things and act upon them as part of your solution. Next one is the registry. And registry allow you to store information regarding your things. So everything from serial number to all kinds of metadata, and you can define different fields and store different information. You can take things and put them into groups. You can create jobs for a specific group or for a specific device. And this is the part when you're doing your inventory. And this inventory is in the cloud. And last but not least is everything related to Shadow. Shadow is a representation of your thing in the cloud. So take, for example, an air conditioning system that you set to 25 degrees. And you want to change it with your mobile application. Your mobile application will access the shadow of this specific air conditioning unit, will change it to 23 degrees. I like it when it's freezing, 21. And I will send this command from my mobile device, will update the shadow, and the device will read the shadow from the cloud, will change the temperature, and only after applying this change will report back that it was actually done, and my application will get it back saying that this cycle is fully closed. And even if the device is offline, I can still send the command to change the temperature. It won't be changed and it won't be acknowledged until my thing will actually connect to the shadow and take this new information. And it can be super simple, like setting up a temperature, a single number, or a single variable. It can be a bit more complex, like having different messages, having different types of information. Simple JSON format. You can design your own shadows any way you want. Let's play a bit with shadows. Want to play a bit? It's late, so let's do some demos. If you have a QR code, you're more than welcome to scan the QR code from the screen. I think it's working even from the end. You'll tell me in a second. If not, there is a URL here at the top that will take you to a page that looks like this. I'll give you 10 seconds to get to the page, and I'll switch to my demo for a second. Ready? You have the URL on the right, if you're still looking for it. Okay? It's over here. Good to go? Let's play. So you have a light bulb on your phones right now, and I can actually control this light bulb from this application. So right now it's turned off, and if I'll click here, did it work? Unbelievable. Okay, so now I can play with this light bulb and change the number to any number I want, and it should instantly update on your phones based on the number I'm setting up on my control application. And this is playing with the device shadow of this virtual light bulb, and I can play with it as much as I want. If you want to see what's happening inside AWS IoT Core, so this is the console of AWS IoT. I'm right now in my Manage Things page, and I will go to this specific light bulb, my virtual light bulb. I'll go to Shadow, and as you can see, I'll scroll a bit. Right now, the reported number is brightness 100. If I'll put it down to 42, it will instantly update to 42, and your devices will read this number and update on your end to the same number. And this is how device shadow works. And let me show you what is happening behind the scenes. So what I was doing here is taking a very simple web app on my end, which is the controller, talking to AWS IoT, changing shadow by this very simple slider. On the other end, all the devices, all the smart light bulb on your phones were connecting with another application to the same shadow, and constantly with WebSockets reading this shadow and changing the representation on your phone immediately. One of the things I wanted to show you here is the fact you're using right now a service that you don't need to manage, you don't need to scale, can solve this in a room of several people like we are here. And I did the exact demo for 500 people, for 900 people, and it worked exactly the same. Same performance, it was relatively speedy. I don't know, I didn't see the changes on your phones, but usually it happened almost simultaneously, my change and what you see on your end. And I can extend this very simply to other use cases. Like, for example, taking an Alexa, connect it into a Lambda function, and control the light bulb with Alexa, that at the end of the day, the Lambda function will do exactly the same thing I'm doing with my web application. Will change the value of the shadow to something else, and here is a super simple implementation of a smart light bulb that you can implement everywhere with a very simple and very basic setup, and of course, a setup that can scale really, really fast to very large numbers. So this was IoT Core, and now let's talk about things, about the other end of the equation. And when we're talking about things, there are some challenges that we need to solve. And one of those challenges is, where do I want to process my data? And this is a very big question, because when you're connecting your things to the cloud, there are some implications for that. And when you're processing your information locally on those things, there are other implications. And when we are talking about this decision, we need to take several things into account, and we call them laws. And there are actually three patterns or three laws that I would like to discuss. The first one is the law of physics. So first of all, everything related to communication. So when you want to store or process your data in the cloud, you need communication. And you need relatively fast and reliable communication, and it's not always possible. Think about scenarios like IoT in space, or IoT in airplanes, or underwater. We have all kinds of projects that people are syncing IoT devices for all kinds of use cases. Or simply you have unreliable network connectivity. Or another use case that is related to the law of physics is the speed of communication. If you need to make a decision, like for example in an autonomous cars, to decide if to turn right or left to avoid collision, are you going to wait for the decision to be made on the cloud? Are you going to send a question to the cloud saying, should I turn right or left? Until it will come back, it will be too late. And this is simply because there is a limitation for the speed of communication. And you need to take everything into account. The second law is the law of economics. You're dealing with data, and there is a cost associated with shipping this data. And this is super important. And in many cases, when dealing with IoT devices, they're creating a lot of data. And some of this data is irrelevant after a few milliseconds. And some of this data might be very important for you for a later stage analytics, but you don't need all the measurement points. And you can aggregate the data, and you can compress the data, and you can actually decide which data you would like to send to the cloud and which one you're okay with keeping it locally. And the last but not least is the law of the land. Compliance, for example, might prevent you from sending the data to the cloud. From the other end, compliance might make you send a copy of the data just to make sure that you have another copy in case you are losing it on the edge. And all those things should be taken into account when deciding where do I want to process my data. And usually when we're talking about these laws, we're talking about them in the context of pushing the decision to the edge. But the reality is slightly different. It works both directions. So think about, I think I mentioned it already regarding the law of the land, if you need to mandatory copy of your data in the cloud. So it's not binary anymore, like you need to take this decision. Or take, for example, the cost associated with transferring data. So it's true that it might be very expensive to send the data to the cloud, but one of the cheapest storage solutions and hardware solutions and compute solutions are in the cloud. And in many cases, you would like to store this information on the cloud, so you need to make wise decisions where you should put this data and how to store it and which amount of data. So there are all kinds of decisions you need to take. And because this is AWS and we like to give you options, and a lot of options usually. You have many ways to build your IoT solution. But one of the advantages on running on one platform end-to-end, that you're using very common programming models and communication models. And it doesn't really matter at the end of the day if you decide to run a big part of your solution at the edge or run all of it on the cloud. We're trying to provide you a solution that will be simple and more or less the same no matter where you decide to run this. And Greengrass is part of this implementation. And I want to talk about Greengrass and what is it. So first of all, what are we using Greengrass for? So Greengrass is used in many different industries. We see Greengrass today in industrial gateways, automotive, of course, infrastructure, medical devices, agriculture, basically in so many use cases that we see more and more coming. And I just want to take one of them, for example. So I already mentioned the automotive example. And automotive has many challenges with data. And one of them is the amount of data an autonomous car generates per hour. Do you know how much data an autonomous car generates per 1 hour? Somebody wants to guess? Nobody? You're too tired. It's late, I know. 50 gigabytes, not bad. Okay, it's 40 terabytes. Yeah, it was at the tens, but 40 terabytes of data for 1 hour running an autonomous car. If you compress this data, you're getting to a relatively small number of 2 terabytes. This is still huge numbers of data. And in most cases, you have nothing to do with this data later on. It was really important for making a decision on the spot, doing some analytics, maybe changing the temperature inside the car or inside the engine or anything like that, but there is no real need to send it to the cloud. And if you're looking at what is happening with autonomous cars, so after processing and crunching the data, usually what they're sending is a few gigs, 10, 20 gigs per hour of information that is important to be analyzed in a later stage. And this is happening locally, on the edge, on the device itself. So there are many different features that you're getting for AWS Greengrass. And the way we're looking at AWS Greengrass is an extension of AWS IoT to the edge, to the device itself. So we're going to talk about all these features in a few minutes. Some of them are very similar to what we already spoke about with AWS IoT Core, and some of them are very specific to the fact that this is running on the edge. But before we talk about the different features, let me explain a bit what AWS Greengrass is. So first of all, it's software. It's software you need to install onto a gateway. A gateway, a device running at the edge. And today we support some different architectures, so you can install it on any x86, 64 machine. So basically my laptop or just a regular server can be a Greengrass edge. It depends on the amount of computing you need. From the other end, most of my presentations and most of my demos are done with a Raspberry Pi, because it's super easy, it's super cheap to use a Raspberry Pi as a Greengrass gateway. It's based on Linux, so you can run it on Amazon Linux, on different versions of Ubuntu, and on Raspberry. And what you're getting from one hand is the gateway, which is connected to the cloud. And on this gateway, you can decide what you're running on top of it. And you can decide what are the actions you want to do, which type of aggregations, and how this information will be sent to the cloud. The management of the gateway is happening from the cloud. So you need to define this gateway or this Greengrass core. You need to manage it. You're deploying your code on it and deploying your certificates and everything else from the cloud. So you have this centralized management that you can do in one place. From the other end, you have the Greengrass devices. And those are devices that are connected to your core and sending information to the core. Those devices can be connected to the internet or running only on your local LAN. So there is communication between devices and core, but it's not necessarily between devices and the cloud. Although if those devices are connected to the cloud, they can do, for example, auto-discovery. They can query AWS IoT and ask AWS IoT, who is my core? So if you're running multiple cores, those devices can go up, query AWS IoT, get the endpoint of the core, and connect to it automatically. And of course, this is very important when deploying large-scale solutions. And those devices can run different types of code. We're going to talk about a few options later. But we have SDKs for both the core and the devices that allow you to install those SDKs and with very few lines of code to develop solutions that access other AWS resources like storage, like AWS IoT Core, send messages, receive messages, and many other features. So now let's talk about the different features. First one is local messages and triggers. And this is a local version of the message broker. And it exchanges data between your devices and Lambda function on local network without accessing the cloud. So you can work in your local LAN, and it allows you to trigger Lambda functions that are deployed locally at the edge. Your code is running at the edge on the Greengrass core device and perform actions and do changes to your environment based on events. The next service is local actions. And local actions are those Lambda functions. Are you familiar with Lambda? Never heard about Lambda? If I need to speak, I saw at least 3 talks today here about Lambda, so I assume that you heard about this term at least once. And Lambda functions are written in the cloud and deployed locally to your devices, to your cores. And they can be invocated based on messages that are going through your system, or based on changes in shadow or other events. And all operations can be local. You don't need to go to the cloud at all. So in this example that we have here at the bottom of the slide, I have a moisture sensor that's checking the amount of water or the condition of the soil. And if it goes below a certain point, it will change something inside the core that my watering system is connecting to, and it will start watering my smart greenhouse fully automatically without going to the cloud, without asking any external system to make a decision. So this can work completely offline. You don't need to provide internet connectivity for the system. You can deploy it anywhere that you can have a local wireless, and this is the way local action works. The next thing is data and state sync. So same as AWS IoT Core Shadow. This is exactly the same idea. You can store it locally, or you can store it in the cloud. Once again, depends on your exact solution. And you can have a single device shadow controlling one wind turbine. Or you can have your entire fleet of devices looking at the same shadow, and changing one will change all of them. So a lot of flexibility here with the different definitions. And security is the same security bar as we offer on AWS on your local network. And it's using the same certificates and same credentials, and you can define Lambda and its permissions, and that allows you really to build a fully secured solution. Yeah. No, a device is connected to a single shadow, but you can have many devices looking at one shadow. Okay. Next one is local resource access, and this is relatively a new feature. Now your AWS IoT Core can access local resources that are connected to this core. For example, cameras, or your file system, or a robotic arm that is connected in some way. Basically, anything you can map in your operating system, you can connect and access it and send commands locally from your core device. So I mentioned already camera, files, even GPUs. If you have GPUs installed on your core and you need them to process images for machine learning, You can connect to them from your Lambda functions and from your core devices. And that brings me to machine learning inference and the ability to run machine learning on AWS Greengrass. And when we're talking about machine learning solution, usually the challenge we have with the data and training models that we need a lot of resources. We need a lot of computing, we need a lot of storage, and this is provided by the cloud. But when you're done with that, and you have a model that all you want is to be able to get data and give you insights, you want this model to run as close as possible to the data. And if it's for image processing or anything like that, you would like to deploy this model at the edge. And this is what machine learning inference allows you to do. You can take models you've been training in other places using Amazon SageMaker or using other tools and just deploy them at the edge. And we see a lot of implementation of that with image recognition, with voice and sound recognition, with collision avoidance for autonomous cars, for anomaly detection, to decide which information is important, which information is less important, and you can do it at the edge. And once again, this is a relatively new feature that went GA like really, really recently. And a lot of power by combining it with access to GPU and other local resources like cameras or microphones or anything like that. Next one is a protocol adapter for OPC UA. And OPC UA is a very well-known standard in industrial machines, a popular exchange protocol that used in factories, in transportation, in logistics, and many other places. And our customers came to us and asked us to provide a way to connect existing devices that they have already deployed in their factories to Greengrass and to AWS IoT Core. And this is our implementation of this solution. And the way we implemented it actually allow you to use additional protocols by changing the implementation by your own. And if you have a specific protocol that you need to support and connect to some kind of industrial machine that does not work with OPC UA and works with something else, you're free to do that, and you have all the flexibility to run it the way you need inside your factory or inside the car or anything else you're doing. Last one is over-the-air updates. Once again, one of the latest features we released allow you to update your Greengrass cores over the air and allow you to do it automatically. You have to remember that you're still in control. We won't update for you unless you ask us to do it automatically. And the way we are versioning our releases, like maintenance version, minor version, major version, allow you to decide which one of them will be done automatically and which one you'll have to approve or trigger by your own. And we already have many customers using Greengrass in production, and we have many partners that are working with us to build devices that can support Greengrass out of the box. And I want to give you one example of one of our customers that is called Rio Tinto. Familiar with Rio Tinto? It's a huge mining company, like huge. I was doing this talk in South Africa, and everybody knew Rio Tinto. So it probably depends who are the audience. So Rio Tinto is a huge mining company, and they're running mines all over the world. They have a lot of what it's called open pit mines, those huge holes in the ground. And if you can see, there is a truck here. I'm not sure I'll put it like this. There's a yellow truck here. That this truck is going up and down those mines and bringing all kinds of materials from the bottom of the mine to the surface. And there is a huge challenge with those trucks. You know what the challenge is? Tire wear. Those trucks are using between 8 and 10 tires. Each tire costs, now take another guess, it was not that good last time, between 40 and 100K per tire, a single tire. And one of the things that creates the biggest damage to those tires is the quality of the roads inside those mines. And what Rio Tinto used to do is to send inspectors once in a while to go check the roads, and if something is broken and can be fixed, they were going to send a team and going to try and improve the quality of the road. And then came IoT and Greengrass, and they decided to automate this process completely. So they're using sensors that are available on these trucks connected to Greengrass core, and those sensors are sending information regarding the vibration, and this is equivalent to the road quality, to those Greengrass devices. Those Greengrass devices will take this information, aggregate it, because you don't need 100 samples a second, 10 or even 1 usually is enough. Store this information locally because there is no internet connectivity usually at the bottom of those mines. It's only when it's going back to the surface. And when it's going back to the surface, it will transmit this information back into AWS IoT to the cloud. And what they're getting is those live heat maps of their mines that's showing them exactly the quality of the roads inside their mines in near real time. And one of the nicest things about this project, you know how long it took them to implement it end to end?
6 months.
6 months. Nice. You really suck today with all your guesses. I'm sorry. 2 weeks. 2 weeks, guys. This is that simple. Because most of the components they were using were already existing, and they just had to tie everything together with different components. Greengrass at the edge, AWS IoT on the other end. Creating this heat map is pretty simple. Of course, every measurement comes with the GPS location, so you don't have only the vibration information, you have the location of it as well. Connecting this information together, storing it in a very simple database, and generating those heat maps on the fly. And by using Greengrass, you're getting many benefits. So first of all, you can respond much quickly to local events. I mentioned car industries before, and of course there are other examples, but there are things that needs to happen instantly. And the only way to do it is doing it locally, because the time it will take you to go and come back from the cloud is usually too long in those cases. The other thing is the ability to operate offline. Same example as Rio Tinto, and we have many other examples that our customers are doing. I mentioned earlier all kind of research that has been done below sea level, all kind of machines that are disconnected. You can operate offline, and you can decide if you need to take the data and ship it to the cloud when you're going back online. It simplifies your device programming. Because we're using Lambda, it makes the life of developers much easier. And if you had the pleasure to develop for IoT devices in the past, for embedded devices in the past, it's not that simple, and you need special expertise. And today, companies can take the same people that are developing their web application and ask them to develop logic for their IoT devices, because it's the same language. We're allowing people to develop today in Python, in Java, in Node.js on their edge devices, and that makes the development much simpler. Of course, reduce the cost of IoT applications, mainly by aggregating data and working locally. That will reduce dramatically the cost of your application. And you need to take into account that today, with IoT devices, especially IoT devices that are working on 3G, 4G, 5G networks, it can be very, very expensive to send data. And there are all kinds of pricing models for that. But when you are able to do aggregations and do them locally, this is something that can dramatically affect the cost of your application. Last but, of course, not least, security, super important. And you're getting AWS great security end-to-end. And this is a very important point. And that will probably prevent from the DOL from the previous session to be that unsecured. And if you're doing it right, you can have a solution that is super secured and using latest technologies, including additional tools that we provide, like, for example, rotating your certificates once in a while, just in case, or having all kinds of restrictions in additional tools, not only certificates. So those are the benefits. And this is what we're getting for the gateway. But the gateway is working with endpoints. And while Greengrass is for devices that can actually run Greengrass, we have some challenges with the endpoints, because in many cases, the endpoints are running microcontrollers, And in many cases, you can't deploy Greengrass or a simple SDK on those controllers because they're simply too small, too simple. And since they are super cheap today, we see them everywhere. Today, when you can buy a microcontroller for $1, sometimes even less, you need something that will be able to run on those microcontrollers. And for that, we introduced, at the end of last year, Amazon FreeRTOS. And this is IoT microcontroller operating system based on the open source FreeRTOS that can allow you to use AWS resources with those microcontrollers. And if you're taking a microcontroller and install FreeRTOS on top of that, and I managed to do it with all kinds of controllers recently, the cheap ones and the more expensive ones, you're getting several important features. First of all, local connectivity libraries for AWS Greengrass. So now you can connect with just a few lines of code to a local Greengrass core and connect those devices and get all the information in one place. If you have network connectivity, if your microcontroller includes a network that can actually access the internet, you can connect directly to AWS IoT Core. So you have both options, locally and on the cloud. It has all the security features that are needed to make those connections fully secured. And we are working on several features, including over-the-air updates and code signing for those specific controllers. And I'm sure that many other features will be added in a later stage. And I just want to give you one last example, which I think is super cool, and working with a lot of different sensors and controllers. And Warby Parker is one of our customers, and they are offering designer eyewear. And I see a lot of people with glasses here, and you know how expensive it is usually. And they are trying to lower the price for those frames and this entire industry of eyewear. And they started as an online business and moved to physical stores relatively recently, just a few years ago. And they use data coming from their stores to inform product decisions, actually to do something that we are very used to in the online world, in the physical world. So when we're looking at the online world and we're measuring unique visitors, when we're looking at the physical store, we want to see foot traffic. How many people went into the store? And when we're talking about clickstream, we're talking about stay zones. How much time people spend in front of a product. And add to cart is product interactions. If I actually reach to the product and tried it myself, that's more or less equivalent to add to cart. And what they are trying to do, and they're doing it with AWS IoT and Greengrass, is to take those numbers that they used to have in online store for free and get them with different sensors and different tools in a physical store. And what they're doing right now is running Lambda on top of Greengrass to aggregate information coming from all these different sensors and then sending it to AWS IoT for additional analysis, and then they able to make decisions like where they should place which products, what is the right layout for each store, and they can play with it. They can do actual A/B testing with physical stores. They can have one store in Manhattan with one layout, another store with a different layout, and after 2 weeks to compare between the numbers and being able to say which one works better, and once again, with Greengrass and Lambda. And one of the reasons they moved to this solution is because what we were talking before regarding the simplicity of the development. They have a large team of web developers that used to develop their stores, and now the same developers are developing the same Lambda functions to run on top of the Greengrass core devices to get this information, analyze it, and send it to the cloud. More or less, just another web app, but with physical devices and with physical sensors. So, as you saw, we provide you with an end-to-end IoT solution. And from the devices running at the edge with FreeRTOS or any other operating system with our SDKs, to the gateways, and to the cloud with all the different features that we provide there. All you need to do is to come up with your next cool solution, and it's completely up to you. Easy, right? So thank you very much. Don't forget to rate the session, and if you have any questions, I'll be more than happy to answer them. Thank you. There are questions?
I do have a couple of questions here.
Already?
Regarding the FreeRTOS OS,
Yeah.
How much space does it actually take?
I don't remember. It's a very good question, but I managed to install FreeRTOS on really cheap, small devices. I don't remember the number, but it's documented. Who asked this? So I know my answer. It's documented. I know it's an issue, but with the certificates and FreeRTOS, you can actually have enough space to put your code on top of this device.
Does it run on the ESP?
Which one?
8266?
Yeah, I tried it. Yeah, obviously. And 32. So this is the last two I tried it on.
What are the costs for Greengrass? Is it suitable for hobby use?
So the cost for Greengrass, if you're running it offline, is almost nothing. And the cost is only when you're accessing the cloud. And there is pricing for sending information to AWS IoT Core, and you're paying for that. The prices are super low, especially if you're talking about an hobby use and not an industrial use when there are millions and tens of millions of messages every day. If we're talking about small numbers, it's usually not expensive at all. And you have to remember that there is a free tier for the first year of usage of AWS IoT. And for many cases of playing with your own smart home or something like that, it should be enough for a very minimal pay.
I have a question here saying, how do you transmit data to AWS offline? Well, I guess you don't.
You don't. You need to be. You need to reconnect or retry to connect or retry to transmit when you have a network. The cloud is problematic. Let's just to see if the.
I was wondering, you mentioned that there's 3 languages that you support right now?
Yeah.
So the number of supported languages is lower than in Lambda?
Yeah, it is.
Could you repeat the question?
Yes, sure. I was mentioning the languages that Lambda on AWS Greengrass supports. Right now is Python, Node.js, and Java. Lambda on the cloud supports Go and .NET, and I think that's it.
And Python 3, I think.
Yeah, and Python 3, and on Greengrass it's only 2.7. Yeah, you're right. But yeah, this is the case. But once again, Java and Node.js were added recently. We'll see if there are additional ones coming.
Are there other limitations, like within the languages that you support? Are you aware of them?
Nothing I can think about right now.
More
questions?
So when the device is still offline, you can imagine it has to keep like a stack of data until it gets to upload.
Yeah.
Does it often happen that memory runs out on the device?
Please repeat the
yeah,
question.
I'll repeat the question. So when devices are offline, is it happening a lot that devices are running out of memory or out of additional types of storage? So it depends. It actually depends. You need to design your solution accordingly. If you are going to scenarios when you're going to be offline a lot of time, you need to provide some kind of storage. It can be even external storage. You need to select your core device based on the specific use case. Today, even with memory sticks, you can get enormous amount of storage on Raspberry Pi. But once again, it really depends on your use case. And we're not talking about microcontrollers for cores. Microcontrollers can't be Greengrass cores. Okay? Yeah. You'll tell me how we're doing with time. Okay?
So for the FreeRTOS system, do you make sure that it's compatible with a lot of devices, or is it like on a log basis, like whether or not it's supported? Or?
So I don't know the exact roadmap regarding which devices are going to be supported, but it's more or less parallel to the open source FreeRTOS. You can just follow that.
Okay. Thanks for being here today.
Thank you very much.
And thank you.
Thank you.